geometric sequence is only introduced in grade 12 because it's slightly more complex as compared to the linear and the quadratic. Okay? The geometric sequence is also called the exponential sequence because it's more like it's exponential in nature. Okay? So you have to know your exponents from grade 10 and 11 for you to be able to do calculations on the geometric sequence. Okay, this is a new sequence, right? So a geometric sequence, okay, it is a sequence that has a common ratio, which we denote by a small letter r. Okay, the common ratio is denoted by a small letter r. So there's a common ratio between successive terms. Okay, so to obtain the next term, you multiply the previous term by a specific value. That value is called the common ratio, right? So the common ratio is always equal to T2 over T1. It's also equal to T3 over T2. Okay? Generally, we can write this Tn over Tn minus 1. By now, I expect you to understand this notation because it's a very common notation in grade 12. Okay? So your common ratio can be calculated by dividing the next term by the one before it. So T2 over T1, T3 over T2, T4 over T3, T5 over T4, and so on. Okay? And please be aware that the geometric sequence does not have a common difference. It has got a common ratio, which means there is multiplication which is involved. Right? And our T1 is equal to A, like in the case of the arithmetic sequence. Okay, that's one of the similarities between the arithmetic and the geometric. T1 is also equal to A. Right? Now, the general term of a geometric sequence is Tn equal to A times r to the power of n minus 1. Okay? It's Tn equal to A times r to the power of n minus 1. Please be aware that this n minus 1 is an exponent of r only. It does not affect the A in terms of being an exponent. So the A has got an exponent which is a 1. The exponent of the r is n minus 1. So this is your general term. Okay. Tn equal to A times r to the power of n minus 1. Thanks, Ben. But we have got any questions there? Is there anyone who has any question? So you have to memorize the formula for calculating the common ratio, but it's very simple. T2 over T1, T3 over T2, and so on. The first term, T1, is equal to 8, like in the case of the arithmetic sequence. The general term is Tn equal to 8 times r to the power of n minus 1. Can I move on there? Right. So on the next page, right, we can write the terms in a geometric sequence using A, the first term, R, the common ratio, N, the position of the term, or the number of terms, right? So the first term is A. The second term is going to be A times the common ratio, so AR. The third term will be AR squared, right? The last term is going to be AR to the power of -1. That last term, that's where we get our general term, because it's equivalent to Tn. So Tn becomes equal to AR to the power of n minus 1. Okay, just for interest's sake, just to check whether you're following what I've been talking about. what will be the value of a term before the last one? It will be AR to the power of n minus 2. Thank you. All right? So that's straightforward. Right, so make sure you remember this. I'm going to come back to it again when we derive the formula for calculating the sum of the terms in a geometric series, which I'll do probably by Friday. All right? So let's do some examples. Okay, these examples are from Platinum Maths, okay, which is your prescribed text within the school. Though I don't like it much, but I'll also refer you to Mind Action Series as well. Right, so what I did here, I just chose a few questions. I won't do every question in the exercise. I'll choose specific questions. So I chose 1B. Okay. So 1B, we are supposed to answer these 4 questions based on that sequence B. So for each of these sequences, you must answer these 4 questions. Right? So I chose what? B. Okay. So the first term of that geometric sequence is 1 over 8, the second one a quarter, third one a half, 1, 2, up to 128. So the first question says, write down the 5th term in the sequence. Right? Now, to find the 5th term, it is better for you to calculate the common ratio first. So the common ratio is going to be T2 over T1. Our T2 is 1 quarter, T1, 1 over 8. If you divide 1 over 8 by, 1 quarter by 1 over 8, you get a 2. Okay? Because a quarter is 2 times 1/8. Right? So the common ratio is going to be a 2. So for me to get the 5th term, all I have to do is multiply the 4th term by 2. So my 5th term is going to be a 2. It comes from here. Here. Right? The first term is A, second term is AR, third term is AR squared. As you can see here, to get the next term, you are multiplying the previous term by R. So for our sequence here, we are given the 4th term as a 1. But the common ratio is a 2. Therefore, the 5th term is going to be the 4th term times the common ratio, which will be 1 times 2. That will give you a 2. If you want to test whether that's correct, recalculate the common ratio. Right? So 2 divided by 1 gives you what? A 2, which is the common ratio. 1 divided by half is also a 2, which is the common ratio. Are you following? Right, so I answered 1.1. Then 1.2 says, determine a formula for the nth term of this sequence. Right? So we need to find a general term that we can use to calculate all the terms in the geometric sequence. To do that, we have to use this formula Tn equal to AR to the power of n minus 1. So you need to know the first term and the common ratio. Okay? Our first term is given as 1 over 8. We found the common ratio, it's a 2. So on the next page, our common ratio is 2. And the first term is 1 over 8. Are you following that? Right? Then our general term is Tn equal to 8 times r to the power of n minus 1. Right? Then you substitute where there's a, you put 1 over 8. Where there's r, you put 2. Then you apply your knowledge of exponents. If you forgot exponents, then you have to refresh yourself. And I can share with you a grade 11 book. Okay, to refresh your knowledge of exponents. So from here, well, we can leave the answer like that. But be aware that for this question, we can simplify it further by using our knowledge of exponents. So this 1 over 8 can be written as 2 to the power of negative 3 times 2 to the power of to the power of n minus 1. Then, since the bases are the same, you add the exponents. So you end up getting n minus 4. So that this general term here can be simplified to 2 to the power of n minus 4. Okay? Your knowledge of exponents is required when it comes to the geometric sequence and also the geometric series. Exponents. Yes.
But that's if they all can be in simplest form.
Yeah, but I encourage you guys to simplify it.
So what do you think they do?
Okay, if they don't specify, maybe depending on the mass allocation, you also might have to look at the mass allocation. Okay, you are in grade 12 now. I expect you all to know that 1 over 8 is the same as 2 to the power of negative 3. Yeah, you know what? You should know it like this. Okay? Like the way that your eyes blink. You should not take long to say, what is 1 over 8? No. 1 over 8 to the power of negative 3. If I come to your house whilst your pastor sleeping, I wake you up, you must tell me straight away. Okay? Yeah. Alright. Okay. So you're supposed to know that. Just imagine if you go to a mall and then and then listen. Okay. Is there anybody else with any question? I'm not going to introduce the geometric series today.